we'll try to deal with another shear force, which will be the force in the y direction, negative y direction. So again, the steps to do this is also draw the cross-sectional area. And then try to draw the force. So this time we are going to draw the force in the negative y direction. So which means we will know the neutral axis will be x-axis. So now let's take a look. Which one will be 0? Yes, Q. So which means we can write the stress at B cube. So now let's try to calculate the shear stress at A and A prime. They are going to be the same because they are at the same cut. So which means we are going to use VQIT again. So can we use the previous result? The answer is no. Why? Because our shear force changed. It's not 1500, it's actually 1000. And again, cutting width will be diameter. So don't be lazy. You have to do the calculation every time. Otherwise, the force changed, your stress will change. So now this time, how could we identify the shear stress direction at A and A prime location? Again, you can see it will be in the same direction of the force. So which means we are going to draw the shear stress in the negative y direction. And then after this, we can use head by head. The value for each one will be. Okay, so we finished the force, then which means we can move to the moment. And again, try to do the torque first, because compared to the torque, bending moment is a little bit hard. So the torque will create shear stress. We are going to use T rho over J to calculate. So how could we solve this problem? Again, try to draw the cross-sectional area at the cutting point. And then what we need to do is try to draw the force. So how could we draw the direction of the torque? So this is what you need to go back to the FBD. You can see our moment is mz is go to the negative z direction, which means you are going to curl your hand. You can see we actually start from A and then move to B point and then curl to A prime point. So which means your direction of the torque is actually go clockwise. So now what we are going to do is identify the direction of the shear stress. Well, the shear stress at A prime B will be the same direction. The answer is no, because for the torque, it's actually going to create a shear flow going in the same direction. So you can see A is go to the negative y direction. So this is what we need to do. However, when it's passing through B, you have to go to the negative x direction. And then when our forefinger passing through A prime, it's actually going down, which is the positive y direction. So which means we have to draw the shear stress in a positive y direction for A prime point. And then after this, it will be head by head, tail by tail. So how much is this? We are going to use T rho over J to calculate. So the torque is in, what is the rho? Yes, radius. How could we calculate J? Pi over 4 again? No. J is different. It will be doubled, so pi over 2, r force. So are we going to use this, all the numbers we listed here in your calculator? The answer is no. You have to be careful. The units, we have to multiply 1,000 here. Otherwise, your unit is not the same, you get different answer. So you can see the stresses is the same because it's the same equation, the same load. However, they all go to the different direction. Be very careful. And then we will be able to move into the bending moment. So for bending moment, it's actually going to create a normal stress. We are going to use my over I to calculate the normal stress, the flexural stress. So again, what we are going to do is still draw the whole cross-sectional area. So now, how could we identify the neutral axis? So the bending moment is going to curl around the neutral axis. So you can see right now your thumb is in the x direction, which means we are going to curl around the x-axis. So which means x-axis is going to be our neutral axis. So which point will be 0? Is that going to be B or A? The answer will be A and A prime. Why? Because the y will be 0. It's on the neutral axis, so the y will be 0. So now let's try to calculate B. My over I. Again, for this problem, remember, change the unit to the same. Y, what is the y? For B location, it will be radius. So again, calculate I and calculate J is different, okay? So we are going to use pi over 4. So now, after we do this calculation, the next thing we are going to think about is actually, is B under tension or compression, is that right? So how could we tell? Then what you need to do is curl your hand, okay? So you can see from your FBD, this is your neutral axis, x-axis. And then you can see on the B end, it actually needs to have the stresses going down. And then on another end, it has to go up here so that when you curl, following these two arrows, you are going to have positive bending moment around the x-axis. So which means your stress will be in the same direction. So B is actually on the tension side. And the lower part will be on the compression side. So are we going to draw this tension on the side face, top bottom face, or the front and the back face? Always remember, stick to your cutting plane. So on the cutting plane, it is the bottom, so which means we are going to draw the stress in the Z direction. Okay, so we still had one more force to go. So again, which axis will be the neutral axis? And then which one will be 0? Yes, B. YB, B is on the neutral axis, so YB will be 0. So we are going to get the same value from my over I. However, is A and A prime all under the tension, all under the compression? The answer is no. They got to be different. So again, how we are going to identify this? Try to draw the neutral axis on your FBD. And then you can see if you want to curl your hand to get the moment in the positive Y direction, then you have to reach down at A and then kick back at A prime like this. So which means A is under tension, A prime is under compression. Alright, we finish all of them, all the stresses for different components, which means the last thing we are going to do is actually trying to summarize them all. So what you need to do right now is be carefully add the shear stress together, the normal stress together. Okay, if they were in a different direction, it's not just numerically add the numbers up. Okay, watch the direction. So after you summarize them together, you can find out at the same cutting point, at a different location, we actually had totally different stress cube and stress element. So if we were trying to convert it to the 2D, for the A point, you just need to take a look from the X direction or negative X direction, and then you are going to have and for point A prime, I still take a look from the negative X direction. For B, what you need to do is actually take a look from the negative Y direction. Can we take a look from positive Y direction? Yes, the answer is yes. As long as you follow your own direction, we are going to get the same stress element.